Good morning, aspiring mathematicians. This morning we are going to take a look at variables and expressions. It's probably been a hot minute since you talked about expressions and variables, so we'll give you a little bit of a refresher first. Remember that a variable is a letter that represents a number. Letters were easy to use. We easily could have chosen to use symbols or little pictures, but letters were the easiest one to use. An expression is a series of mathematical terms with numbers and letters I guess I should say variables connected by addition, subtraction, multiplication, and division. The one thing that is missing, you will never have an equal sign. When there is an expression. We reserve equal signs for equations. Now, most of these have directions that say evaluate. That is a fancy math term for plug in the number and do the math. That math can be done by hand. It can be done in Desmos. Personally, I recommend Desmos, but that is totally your choice. So here we go. I like to think of expressions like this as a place where we're going to dig a hole. And we're going to dig a hole everywhere there's a variable. So my first step is going to be to rewrite the expression, leaving holes where the variables should be. Then I'm going to fill in the holes because you can't leave a hole out in the middle of your yard. Somebody's going to fall in, then you get sued, and nobody's got enough money for that. So we have to fill in the hole with something. Well, the directions happen to tell me that the dirt for my M hole is a 7. So I'm going to put the 7 everywhere I had an M. Then it tells me that for an N, I'm going to fill the hole with an 8. All of my holes are filled up. Nobody's going to fall in. I'm not going to get sued. Now it's time to hit the calculator. So I'm going to go over to Desmos and I'm going to enter it just like it looks, parentheses and all. So my final answer when we evaluate n squared minus m squared is 57. So I'm going to look at number 2. Again, I'm going to start by making my holes. When I make my holes, though, I need to make sure that I leave this set of parentheses in place. I don't want to get rid of those. So I need a hole where the x is and a hole where the y is. This says to put the 5 in the x hole, so I'm going to fill that one up. Then I'm going to put the 2 in the y spot. I don't have any more holes, so it's time to go to the calculator. Again, I'm going to type it in just like it looks, and that means I'm going to have to use double parentheses. But that's okay. So once we evaluate our expression when x is 5 and y is 2 is 24. Now, could you get the same answer without these parentheses? Yes. So why do I make you put them in there? Well, on a lot of these, you can get the same answer, but on some of them, you will not. And so it's a really good habit to get into to keep putting in those parentheses so that when it really matters, you don't have to think about it. They're already there for you. I'm going to look at 3. But before I start 3, I want to rewrite this expression to make it look a little more familiar. Normally, we would rewrite this as y times x divided by 2. That's the way you guys are a little more used to seeing these, and it's totally fine to go and rewrite that before you start. So there's my y hole. There's my x hole. And the 2 stays a 2. This says I need to use 7 as my x dirt. So I fill up the x hole with a 7. Then I'm going to fill up the y hole with the 2. Then I go to my calculator and I get a 2 and a 7. So I end up, when I evaluate this expression, with a 7. Now, some of you may be able to go and simplify this guy without using Desmos. If you can, you're welcome to, but you absolutely don't have to. Here's what it would look like if you simplify without Desmos. You have the parentheses divided by 2. Now, a long time ago, in a galaxy far away, you learned that this could be rewritten as 2 over 2 times 7 over 1. Well, when you were knee-high to a very small knee, you learned that 2 divided by itself is just 1. And that 1 times anything was that thing. So you can arrive at 7 either way you feel comfortable. I don't know, there's my 7. Four is a little bit different. 4, I want you to notice that the division only applies to the n. Over on number 3, division applied to both of them because we didn't have an add or subtract between the w and the y and the x. On 4, however, if I were going to rewrite this in a way that you guys are a little more familiar with, this would end up being m minus n divided by 4. So make very certain when you're plugging in that you plug it in correctly. So I'm going to rewrite it with my wholes. There's my m whole and my n whole divided by 4. This says the dirt for the m whole is 5. This says the dirt for n is 8. You are welcome to go to Desmos at this point. I'm going to solve it by hand. I'm going to bring down the 5 because I don't have any operators with it. And I know that 8 divided by 4 is 2. Then I know that 5 minus 2 is 3. And that is the end of my evaluation process. If you chose to put it in Desmos, please make sure that the 5 stands alone, that it does not get included in the division process. Because if you include it in that division process, Desmos will only be the fastest way to be wrong. Let's take a look at 6. I want to make sure that you know exactly how to handle that cubed in your calculator, should you choose to use it. I'm going to start out just like all the other ones. I'm going to write it out with my wholes. Make sure that 3 stays on the outside of the parentheses for the x whole. Excuse me. Okay, so I'm going to fill in a 1 for my x whole and a 19 for the z. I'm going to do it by hand, and then I'm going to go and show you how to put that cubed into Desmos. This turns out to be 19 plus 1 cubed is 1 times 1 times 1. Well, that's just 1. So it turns out to be 19 plus 1. And last time I checked, that was still 20. For Desmos, when you go to plug this guy in, not like that, plus 1, and you need a cubed right next to the a squared button that you would normally use to square a value. There is a button that says a to the b. If you tap that little guy, it will let you put in whatever exponent you want to. You can put a 3, you can put a 2.5, whatever you need to put up there. So that is where you would put in a cubed, a fourth power, anything I ask. If you want to get in the habit of just using that A to the B button for anything, then you don't have to worry about the squared button. Because plugging in a 2 right there is always an option. I'm looking for one that might look a little scary. Let's do I'm going to do 12 because it's got some multiplying in there and I want to make sure you don't miss it. I'm going to start out with my holes again. There's the one for P. I have one for Q and one for P. So 7 gets put in for P. And 4 fills up the spot for Q. I don't know how much you remember about order of operations, but if you're doing this one by hand, we can bring down the 7. Because the first thing after parentheses and exponents, we multiply and divide from left to right. So my next line would be a 28. Then I add and subtract in the order I come to them. So I know 7 minus 2 is 5. 5 plus 28 is 33. If you want to plug it into Desmos, by all means, feel free to do that. The only other thing I would caution you about is on 11, that little division part right there. Please make sure you only apply the 2 to the y. And on 8, make sure you only apply the 6 to the q. So be careful in those two places. The other thing we have is a few word problems, and I know those make some of you twitchy, but you're going to be okay. We'll take it step by step. Some of these, you may not even need a formula. Some of them you may just be able to reason your way through. So we have Norman here. I'm sure he is a perfectly delightful chap. And he has a sunflower farm. He uses a plot of land that is 3 kilometers by 4.3 kilometers. How much land does he use for his sunflowers? Well, right now, I know I need a picture because my brain thinks better with pictures. So here's a bird's eye view of Norman's plot of land. 3 kilometers by 4.3 kilometers. I know some of you probably think that drawing pictures is dumb. It might make you look silly because you had to draw the picture and somebody else didn't. But here's the thing. If drawing a picture makes your life easier and it helps you get it right, use the extra 30 seconds to draw a picture to get those points. Now, if I want to know how much land is covered by sunflowers, remember area is the concept that covers. So we need the area of that rectangle. And a long time ago, like last week, you looked at area. And we used area was length times width, or you could use base times height. Same destination. So we need to multiply 4.3 times 3. Not 43, 4.3. So Norman has 12.9 square kilometers of land dedicated to his sunflowers. Two is similar. I'll set up the picture because, again, pictures work really well for me. Joanne is creating a triangular shaped vegetable garden and needs to put down fertilizer to cover the space. If the garden has a base of 1.4 meters, and a height of 2.6. So there's my line for the height, and it's 2.6 meters. How much fertilizer will she need? Again, when you fertilize something, you want to cover the area of your garden in fertilizer. Area of a triangle is half of the base times the height. So you have a base and a height that you can plug in. Number 3 shouldn't be a big deal. That is straight up subtraction. 4 and 5 are similar problems. So we'll pick one of them. We'll look at 5. The farmer needs to buy fencing. Well, when I hear about fencing, I immediately think perimeter, especially when we talk about going around. And I remember that perimeter means I add all the sides. So I'm going to put some sides on my picture. The garden is 200 feet long by 150 feet wide. My drawing is not to scale. How much fence will I need? Well, it's safe to assume in this case that we have a rectangle. Since they just gave us length and width, it's a safe assumption. And I know, and you should know by now, that that means opposite sides are equal. So to find the fencing, I need 2 200s and 2 150s. So that's 400 plus 300. So it looks like our farmer needs 400 feet of fencing. The last one, Mike and his 3 friends decided to divide a bill evenly. If each person paid $13, what was the total bill? So Mike and his 3 friends. That tells me that there are 4 people total. And the other thing that I know is that each person paid $13. So $13 times 4 people is $52 for that total bill. That is the end of 3.1. Make sure you let me know if you have any questions. I'll catch you guys later.